welcome to Sustain Now, where we discuss the newest solutions to address the climate crisis. In this episode, we explore the intersection of AI and sustainability with Berk Birand, founder of Fero Labs. Industrial manufacturing is a major source of emissions, but factories often run inefficiently due to outdated systems and lack of optimization. Fero Labs uses AI to make factories more efficient, reducing waste, emissions, and costs without requiring expensive new infrastructure. Berk explains how AI can continuously optimize industrial processes, predicting and preventing inefficiencies in real time. He also discusses the evolving role of sustainability in manufacturing and how AI is helping industries adapt to stricter regulations and changing economic pressures. With a background in electrical engineering and computer science, Berk brings a deep technical perspective on how AI can drive efficiency while making sustainability profitable. Whether you're interested in AI, industrial efficiency, or the future of sustainable manufacturing, this episode offers valuable insights. Let's dive in.
Berk, thank you so much for joining my podcast today. I'm very excited to talk about something very relevant right now, AI and sustainability. What a mix.
It is an interesting mix, and it's definitely an interesting time to talk about this mix.
So before we dive into AI and sustainability, let's break the ice a little bit. I just said it before, it's not so easy to find something about you personally. So I thought I'm going to spice it a little bit up at the beginning. So if someone were to describe you at a dinner party, what's the funniest and most unexpected thing they would say about you?
I think the most unexpected thing would be if it's in a dinner party context. I've gotten really deep into cooking stews and curries in the past few years, and I've discovered or rediscovered the electric pressure cooker, and I've gone deep off the deep end. So I love making curries from across the world, from India to Thailand, and I think potentially the dinner party is one in which I am serving one of those curries.
So you're putting a lot of pressure to pressure cooking.
Exactly. A lot of pressure and then release all the pressure, and the outcome is fantastic.
I love this. So were you like this already? What did you study exactly? Like I tried to get the right name on that. Can you explain a little bit what you exactly studied?
Yeah, my PhD was in the electrical engineering and computer science area, so officially in the EE department, but I did research in theoretical part of electrical engineering, so it was in this weird intersection where electrical engineers wouldn't consider me an electrical engineer because I didn't work with volts and circuits and resistances. Computer scientists would think I'm too practical, so I wasn't too theoretical enough. So I was kind of in the middle between EE, CS, and maybe applied math as the third component. But ultimately, my research was around applying some of these technologies and some of these techniques to wireless optimization and network optimization.
So were you already interested like this as a kid? Like, did you take apart radios or computers, or were you more, on the theoretical side? Were you more practical or theoretical?
I was more practical, definitely. I was more practical. I was definitely the kid who was playing with circuits at a young age, putting together computers, when I was 12. I really got interested in the software side around the same time, I would say 12, 13. I taught myself how to program. I just really liked the idea of creating something, just me sitting in my room as a teenager, creating something. And, at the time, there was places where you could share your software. SaaS wasn't really a thing, so you put it on download.com, and I could, in my little room, create something and put it on some website, and somebody from across the world could find value in it. So that was that's the thing that really got me really interested, which is amazing that we can do this in the software world. If I was interested in civil engineering, I couldn't build a building in my room somehow, or electrical engineering is even more equally complex. But with software, you could just create something with just typing on a keyboard, which was just incredible to me.
Amazing. And what did sparks then to actually study it in the end?
Yeah, I think I really felt like this was a thing that, like my calling, if that makes sense, something that I really could contribute to the world, and use my skills that I've developed just because I was interested in them. And I really thought that this would be something that I could bring to the world in a broader sense, including the entrepreneurship component, which of course came much later after my PhD. But that was also kind of the putting two and two together was an obvious choice for me to go into software engineering and electrical engineering.
I can totally relate. Actually, when I think I was like 15, 16, I started to game, and my mom always called me the seller child. And then I wanted to always to know what is happening when I press the enter. I always wanted to know what is actually happening. So, and I was also like in this middle, like I studied computer science and business administration. And they always said like, you can't really program, you don't really know how business works. So I can really relate to this mix of both sides. And get me through that journey of yours. Like, where have you been growing up? When, where did you go to university? And when was the point actually when you created a PhD and in the end actually resulted into Fero Labs? Like, can you walk me through a little bit that journey you did and what sparked in 2015 to found Fero Labs?
Absolutely. Yeah. So the first part of the journey, so I was born and raised in Turkey. So with Turkish parents. I went to a French high school in Turkey. So throughout my high school studies, I was in the French system, and then kind of wanted to change things up a bit. And the normal trajectory would be to go to France to do the preparatory school and grandes écoles is what they call it. But then, yeah, I think I always wanted to kind of switch things around and be more applied sooner. And so in the US system, typically you get to do cool things sooner than in the French system. So then I switched trajectories a little bit. I came to the US. I went to school in a city called Worcester, Massachusetts, a school called Worcester Polytechnic Institute. It's a small engineering school. Double majored in electrical engineering and computer science. I did my electrical engineering work in the networking space and my computer science work in the cryptography space during my undergrad. So I did research in hardware, random number generators, which is a key component of for securing circuits. And then I knew at the time when I was doing research in these fields that actually I like being in the academic space, and I'm not ready to leave yet. I'm learning a lot. I'm interacting with wonderful people. So that was the impetus to do a PhD. So that's how I ended up at Columbia here in New York, which was also my first arrival to New York almost 16, 17 years ago. And those were fantastic years, just being doing research with fellow PhD students, teaching. I mean, I learned a ton, and I think I started appreciating more and more. First of all, that I didn't want to necessarily continue on the academic trajectory. At some point, I did want to consider going into academia full time as a professor, and so I did want to maybe go into practice a little bit sooner than that. And also doing research in the telecom space, theoretical research, but working with actual circuits was kind of mind opening to me, because I was developing algorithms, let's say for fiber optic networks, and we were collaborating with folks that were building these networks. So I was going to the lab of fellow PhD students. They had set up this 100-mile spool of fiber and actual lasers, and they had set it up, the physical system, and I was coming in with my algorithms and trying to see how we could optimize that and then reduce the problems in transmissions and so forth. And then that's the intersection between intelligence, software intelligence, with the actual physical world, and changing something in the physical world was just the potential that it opened up was really exciting to me. That we could send something in the physical world, do some computation, and change something in the physical world. At the time, there was this hype around, the term Internet of Things. So this notion of the internet, in addition to being humans downloading websites, basically devices and sensors and actuators and smart cities and smart, cars on the highway talking to each other. So that vision was kind of forming, and that was really interesting to me. And so another kind of aspect of my time at Columbia was to meet my two co-founders. One of them was my roommate my first 2 years. He was doing his master's in electrical engineering. And then the other was towards the end of my PhD, my other co-founder, who was doing a postdoc at the time in the data science group at Columbia. So that's kind of how the whole core team came together as well, and realized that we shared a mutual interest in solving interesting problems with technology. The IoT angle of hardware, software, the machine learning, AI angle, and then our third co-founder actually went on to work for GE and spent, he was smart enough to not continue for a PhD. So he spent the rest of his, while I was in a lab, he was working for GE, traveling around the world and to steel factories and chemicals factories. And he would see the problems that they're facing firsthand and the inefficiencies of these giant steel plants in China and in Chile and elsewhere, with these massive flues coming out from them. And that was kind of where all the three components clicked together, and we founded Fero as a result around 2015.
Mm. So you actually never worked like in a company before. That was your first company you were actually being employed yourself into.
Yeah, yeah, that's true. Yeah, that's exactly right. So I had to learn a lot of things from scratch. Some things that are maybe obvious to many, I had to study them. But things like, what does HR do? Yeah, just Google that. So yeah, it was the first official company. I worked on other startup ideas before during my PhD, but none that came as far as Fero. They were more kind of projects of sorts. So yeah, this was the first company that I worked for, and still is.
Can you share one of these projects you worked on and you thought like going backwards, either this was a super stupid idea or that would have been actually a great idea?
So the joke always is that there's this kind of rite of passage type of thing for entrepreneurs, that every entrepreneur has to build a restaurant app at some point in their lives. So I was there. I did my dues and built my restaurant app. I really thought I had an angle. This was at the beginning of my PhD. The advantage of being an engineer, which is also a disadvantage, is that if you have an idea, you can just build it and nothing stops you, which is kind of different for if you come from the business world and you have an idea, you have to find someone to build it. Of course, the disadvantage of this is that, well, you just go ahead and build it without kind of thinking very hard around, is this really a need, or do people, what is the competitive landscape, or is there a market for this, or how does it even turn into an actual thing that exists, self-sustaining entity that exists. So yeah, I did my restaurant app and it didn't work out, which was fine. I think the one that I was really excited about that also didn't exactly work out. We created an arts marketplace for artists, painters, sculptors to send their artwork on. But one of the big problems in the art world is that, clearly young artists, sell their artworks for, relatively cheaper prices. And then ultimately these works go up in price, but then the initial artist doesn't really gain from this at all. And in fact, there are galleries that bulk buy, you know, dozens of artworks from young artists. They keep them in a warehouse for years until the price goes up and the artist becomes a big name, and then they start trickling it to the market. And of course, the artist doesn't get anything out of this. So we wanted to change this a little bit and create an environment, a marketplace that allowed artists to sell their work. But then if the buyer wanted to sell it again, they could sell secondhand on the same platform, and artists would continue getting cuts from that permanently. So that was kind of a way that we thought would be, revolutionizing the art world. That didn't also get very far, and I think my takeaway from that point, I was the CTO of that startup, and my takeaway from that was I should focus on things that I know. I should focus on things that I understand, on the technology side and on the market side, and hence the going back to the more technologically kind of firmer startup, which is fair.
Fantastic. I love these stories that, entrepreneurship is never a straight arrow. It's always going a lot of testing, trying out. And I think many don't talk about that there has been many failures before and testing out other things to actually find then the one which is the right fit for yourself and for the market. When you started 2015 Fero Labs, under which, vision did you started it? Like what were you thinking at that time? What do I want to solve, and why do we think this what we're creating is the right thing?
Yeah, the main problem that we're going to solve was very similar to what we are solving today, which is to make factories more efficient. The interesting angle, was frankly, to it that was really mind-boggling to me is, first of all, one of our co-founders, he was kept saying that, you have, go to these plants across the world and they buy multi-million-dollar worth of control systems, and then within a year, they send an engineer who tunes these systems for months, and then after 6 months the plant is commissioned, and then the engineer leaves, and then a year later the plant goes out of tune again, kind of, and nobody tunes it, and this becomes inefficient and runs inefficiently for years, for 8, 9, 10 years, until they buy another equipment that they reason for someone to come in, or to tune it. And this was quite interesting to me, that why not have a system that tunes the factory continuously, and bring the software in that can do this intelligently. And we thought that there was really a potential here of using our background to make an impact in the real world, to make an impact from, first of all, the engineers' time and engineers' efforts, and allow them to do things efficiently so that they don't have to live in a factory for 6 months to tune something, or so that it happens just automatically. Make the plant's life easier as well in terms of their emission, their compliance. I mean, these are giant plants and they're outputting incredible amount of emissions. And ultimately, so that was the intersection with the sustainability angle, which is, of course, a core part of what we do now. In fact, profitable sustainability is what we call what we do, which is the intersection of both increasing profitability and sustainability at the same time. Using our background, something that we know really well, in order to make somebody else's life, who is not an expert in what we do, and we're not an expert in what they do, that was the thing that really was the sparked the curiosity of like, hey, could we do this? Could we pull this off? And yeah, so here we are now, years later.
It was 10 years,
Yeah,
I think
hard to
it's
believe.
a 10 years anniversary. Can you maybe talk us through an example of a typical project you're working on? How do you see it? Like when you get there, what are the requests you're getting to actually improve, and what you're doing in the end actually improving, and how does it look like?
Yeah, absolutely. It's happy to. So we're active in several sectors, and steel is still one of our core sectors. So in steel, the kind of use cases for Fero usually revolve around reducing waste. And this is kind of an interesting angle because clearly reducing waste has been central to the industrial world for many, many years. This goes back to the Six Sigma, before that, the Toyota production system, lean manufacturing. Factories have different ways of reducing waste, including some of the simple things. Hey, if we move our spare parts from this point to that other point, then we'll have to walk less to get to those parts, and that will save us time, and that's one form of waste. And a lot of these types of improvements, we have nothing to contribute because we're not experts in steel. We know a lot about steel, of course, but that's not our core contribution. Where our contribution comes in is when companies have a lot of data. They have data that is complex, that is real world data, which means that it's not perfect. There's issues with data. There's data that's in different parts of the plant, different groups co-own it in different ways. And a lot of times, a lot of the problems that manufacturers face become effectively data problems. So, something went wrong in the factory. We failed our quality. Let's say, let's give a concrete example. In steel manufacturers, they make steel, and then they have to make sure that the strength of the steel has to be within certain bounds, certain specifications. Let's say this is construction grade steel. Of course, it has to match the strength properties. And let's say they failed. So they spent a lot of energy, a lot of time, a lot of resources building this giant, multi-100-ton batch of steel, and it just didn't work. The strength is wrong. Strength is off. What do? All right, well, let's figure out why. Let's find the data of this particular batch. Let's try to compare it with that previous batches of the same kind. Is it because of how we pressed it? Is it because it wasn't warm enough? Is it because of the chemistry in it? Well, but this other batch had the same chemistry and it did work. Okay, so then it not be this one. And this is, could take weeks, definitely days, but weeks. And sometimes it just becomes so involved that one group goes, well, it's probably the other group's fault, and the other one goes, well, it's probably the other guy's fault, and then they just drop it. Won't get to the bottom of it, so let's just drop it. So these kinds of problems are really well suited for what we do at Fero, because these are the things that AI, machine learning methods are perfectly qualified to solve. Just give it all the data, give it what tell it what you know about the factory and how it's structured, and let it figure out what is unique about this and to understand what caused this problem. And of course, these models can go even beyond that. Instead of trying to troubleshoot what happened before, they can even predict what's going to happen in the future, or allow you to change parameters. We're making steel tomorrow. We had this failure last week. How should we change the process for the next one? Well, Fero can tell them, like, here's how you do it. You add a little bit of less of this ingredient, and you increase your temperatures here a little bit more. And then we'll believe that, this is going to lead to higher strength steel. So a lot of I think to answer your question, a lot of the use cases revolve around digging into data and understanding, improving different efficiency metrics revolving around yield, quality, throughput, and emissions. And typically, in fact, it's all of these at the same time. Because usually factories don't have a single goal. You have different teams. They have a quality team. Their goal is to make sure the quality is high enough. They have the maintenance team. They want to make sure that the equipment lasts as long as possible. So a lot of times these are aligned, but sometimes not aligned. Sometimes the decision that improves the quality is the thing that reduces the timeline of the equipment. And that's where you have to find the sweet spot that maximizes all of these goals. And that's what Fero is also uniquely suited to dig into the data and find that sweet spot that makes everyone happy.
So is the product more like on a project base, or is it something you do like a plug and play? Like you say, okay, I'm just using this Fero Labs, like say data warehouse with all the analysis behind. I'm running my data through and then I get it out. Or do you need to integrate in existing systems? Like how is your product actually working?
Yeah, that's an excellent question. It's a software that runs continuously. So the model that our customers engage in is that we bring in the software and then run a pilot to show them how the software works and help them kind of set up their own first AI systems and AI models for specific use cases they may have in their factory, and help them show them how to use the different tools in the software to troubleshoot problems and get the answers faster and so forth. After that time, we hand over the software to the engineers, and they can use the software to receive the predictions and the recommendations, but they can also use it to build other models and other use cases that might not even know about. They might not even want to tell us about. Maybe this is a side project that they think that, if only we could model this particular aspect of the factory, maybe that would increase our yield and reduce our losses. 3 months into the contract, they could very well just take the data and have the Fero's AI systems have a go at it. And we believe that this model works really well, because ultimately the experts, the real domain experts, are the engineers working in these factories. The consultancy model, we find, does not work very well. Actually, there was a funny anecdote from a couple of years ago. I was talking to a large German manufacturer that had hired a very large data science consultancy in Germany, and they asked him to do some data analysis on their data set, and then they sent the data. The consultancy worked on it for a couple of months, and then they came back with a report, and the report said basically, you're manufacturing 20 types of products. And then, I was, yeah, we know, we manufactured those products. We didn't need your 3 months in expensive payments to figure out how many products. So they had done, some classification and so forth. So it's the I think the interesting takeaway is that the people really that we want to empower are the engineers that understand the problems, that know what works and what doesn't work, and not just generally, but specifically to that one plant that they have most expertise in. And ultimately, our goal is to provide the data infrastructure so that they can do their job better.
And how does sustainability then play a part in this?
So the sustainability part is quite interesting in that the sweet spot that I mentioned around different goals. 20 years ago, sustainability would not be one of the parameters that would affect those different goals, right? There will be goals around cost cutting, profitability. It will be goals around yield, so maximizing the top line, quality, and they would try to find that middle ground that satisfies all of these in terms of the costs. Now there's an additional goal around sustainability that makes things even more complex than before. So now engineers have to deal with all the same problems, plus how do we combine the sustainability angle into this. So for example, in steel, we work a lot with electric arc furnace producers, so producers that melt scrap steel with electricity and then make it into new steel products. And in those cases, the energy comes from the power plant. We have companies, for instance, one of our customers is set up next to a hydropower plant. So their energy is completely, essentially emission-free because they get it from hydropower, but they still have to buy ingredients, and their ingredients still have to be mined across the world. They have to be processed across the world, shipped across the world. So this has a substantial Scope 3 contribution. So now these companies have to both navigate their cost structure in terms of how much we're paying and the supply chains of these ingredients, but also have to factor in, how does the Scope 3 emissions come in? Do we want to buy products that are cheaper but have the higher Scope 3, which will start becoming a key component soon in terms of reporting? Or do we go, okay, we'll just pay more and reduce our cost basis and use a comparatively lower emission ingredient? So the emission component has made these computations much, much more complex. And what we have done to adapt our software is to add emission as a first-class citizen in terms of the optimizations. Previously, the optimizations involved around reducing the cost. So give us how much you're paying for 1 kilogram of your ingredients, how much you're paying for electricity, how much you're paying for running the factory for an hour, and so forth. Now we have added a whole other type of cost function revolving around the emissions. So give us your Scope 1, 2 of your electricity consumption, Scope 3 of your ingredients, and now we'll optimize both in terms of financial cost and environmental cost. And then we can give them a knob. It allows them to tune it, based on where they would like to be. This month, we want to favor, financial costs. Next month, maybe we switch it the other way around. So being able to even have these conversations and being able to have these knobs to tune the way they operate their factory is just a completely new way of thinking about things.
So coming now, you're 10 years on the market, and 2015, probably sustainability, I don't know, you tell me, was probably not on the top of the
It was
agenda
not. It was
of the
not even.
steel industry. And then came sustainability, and now came AI. And how do you see the involvement? Is like sustainability still a big part, or is it now AI driving it? I think you were always a little bit ahead of your time. Probably were called machine learning before. So maybe you can tell us a little bit through, like how did that evolve the public agenda and the perception versus what you have been offering? Like how could you benefit, but also, saw the downside of it?
Yeah, absolutely. So I mean, 10 years ago, sustainability was not one of the top priorities. It kind of goes in cycles. I think, a couple of years ago, maybe 5, 6 years ago, it started becoming more of a top of mind for companies, especially at the board level, I would say. I mean, first at the board level, where a company would make commitments in terms of their 2030 goals. And I think at the time, the narrative was like, well, 2030 is way out there. We have time. We'll figure things out. Until then, who knows? Of course, frequently leadership changes faster than these goals. So therefore, one set of leaders, make commitments, and then somebody else's problem in 5, 10 years. So it was still a narrative, but it started becoming more and more prominent. I think the interesting changes of the past 5 years, I would say, is first of all the pandemic, and of course the supply chain shortages that came from it, completely upended the entire way that factories and the industrial sector was run. Assumptions that companies would make in terms of procuring ingredients in a certain timeline, in terms of kind of sources of ingredients, in terms of workforce, all became very much top of mind. So that was, I think, one of the big changes. And the intersection of the digitization goals with sustainability and the pandemic, I think, created an environment where people felt like, okay, well, we need to do something differently, right? We can't just run our factories the way we've been running our factories for the past 30 years and expect to be around the next 30 years. Like, we need to adapt to the times. There's, at the time, the fourth dimension of this was becoming more and more prominent is the labor shortages, specifically in the industrial sector, which is, of course, more of an issue now and will become more and more of an issue in the Western world specifically. So context, in Germany, I believe since the pandemic, 500,000 industrial manufacturing jobs have been lost. Part of it is, of course, the war in Ukraine, but part of it is also just a general trend of, folks retiring, experienced people retiring, which is making it more and more complicated for manufacturers in the Western world to run production in the Western world. So all of these combined created this kind of environment where, okay, we're now investing in digitization and data because we believe that's the right thing to do for securing the next 30 years of our production. We need to make sure we're much more aware that we can't rely on supply chains to be constant. Things change all the time, and we need to adapt very quickly. Our labor problems are going to get worse and more challenging in the next 5, 10 years. And I think and the sustainability goals is the fourth one, where we're now getting 2030 is not that far out anymore, and we need to do things better in that context. And I believe AI kind of was uniquely suited to help with all of these problems in some ways, and then again finding a way to resolve problems on the labor shortage side by assisting engineers and making their jobs easier so that they can fix problems faster and ideally not have problems in the first place. This helps with the labor shortage side, the environmental side. I think generally the last 5 years were absolutely instrumental for industrial AI. The next 5 years, I think, are going to be even more instrumental when more and more of these systems will come online. And of course, we'll continue to play a key role in that transition. But the interesting angle is that a lot of times when AI is discussed commonly, it's more around its impact on environmental goals because of the LLM specifically having such a large energy consumption impact. And of course, that is the case. And I have some opinions around how that might unfold in the next years. We want to always promote that there's AI systems that don't require that much energy, that can run on a beefy workstation, that can drive sustainability down. And that's where we want to place our bets in.
Would be interesting. Like, imagine we are in the year 2050, where we all want to be net zero. And looking back, how does the world look like for you?
Yeah, it's a great question. I think generally, I don't think we're going through the most optimistic of times. And I think, consumer confidence, and it's just a lot of things are pointing downwards. But I'm still hopeful. I'm very hopeful. I'm hopeful not because I think that magically, humanity will come together and hold hands and make the right decisions that, for the benefit of everyone all of a sudden. I think that's a lofty goal. We hope to get there, but I'm not counting on it. But I think there's certain trends that are already in effect that are hard to stop. And I think there are certain market forces, including, sustainable energy sources becoming cheaper than fossil fuel. In the US, as we all know, there's this drill baby drill motivation top down, and many actually oil and gas companies are going, well, actually, we don't need to drill anymore, or the prices are not where we don't need to. And I think that's going to accelerate more and more unless something major happens. And I do think there will be some breakthroughs on the nuclear side. And I mean, fusion is, of course, would be great, and that's going to solve a lot of problems. But even in terms of small reactors, in terms of reducing the regulation to make nuclear, fission, old school fission, more of a possibility. So I'm really hopeful that technology and science and these developments will actually get us to a kind of net zero type of space. And of course, the AI role of AI in this case will be to make sure that all of this infrastructure is running optimally. So when I think about 2050, I think of it as a time where I like to picture this kind of solar punk view of green buildings and vegetation around them, and then world temperature is now back to below 1.5 degrees Celsius. And I think we can get there. Definitely, we're working to have a minor contribution if we can to help us get there.
Great picture. Let's just imagine it, top of it, like, everyone is meditating.
Exactly. There's some yoga here. And
reading 2 hours of books every day, because the second part, to be a little bit cynical, is what you said, the labor shortage, what you describe right now in engineering. It's, the AI is two-sided. One is, everyone says it's all going to steal our jobs. At the same time, we actually experience a lot of labor shortage. Do you have an opinion about that?
Yeah, this is a topic that's near and dear to my heart. And this is actually, even before starting Fero, I got interested in these topics, just getting into it. What are we getting into here? Are we participating in the largest kind of, change of the macroeconomic environment and the labor workforce? It's funny, at the time, 10 years ago, there were narratives around, truck drivers. That was kind of a big thing. Like, okay, autonomous driving is becoming a thing. In the US, for example, there's like 3 million truck drivers employed. And well, what's going to happen to these 3 million truck drivers once we have autonomous driving, which is imminent, was the feeling at the time. The interesting thing, of course, is that 10 years later, truck drivers are fine. It's the engineers and software engineers that are more at risk, it seems like, that are more threatened by the new developments of the past 2 years. So around that time, 10 years ago, I was looking into the effects of automation. And of course, this is an area that's studied quite a bit. It was studied quite a bit at the time. Specifically in Germany, for example, there was research around the impact of robots in the automotive sector since the 70s and 80s. Kind of this would be if the current AI systems is the fourth industrial revolution, the third industrial revolution was computerization of production, and robots was a key part in it. And when those companies, academics that research in this, it's interesting that they saw the workforce actually going up when robots came about, as opposed to going down. And it was, some jobs went down. Welders, for example, let's say it's not a job that exists necessarily in an automotive production line, but there's now more people that maintain the robots. And so overall, the industrial sector is doing better because they have more consistent, higher efficiency. There are more maintenance type of jobs and robot programmer type of jobs that didn't exist at the time. And as a result, we came out of this with in that third industrial revolution on the positive side for labor generally. Now things are a little bit different now, because now we're talking about AI in the sense that this is a more kind of cognitive, it's not just a physical kind of labor, but cognitive labor. There's a lot of talk around AGI coming in and super intelligence and so forth. I'm not personally sold that necessarily just because we had GPT in the last 2-3 years means that in 3 years we'll have AGI. And you already see companies changing their tune to some degree, the large kind of AI companies. As we all know, the tech sector kind of thrives on making bold claims and raising a lot of money by saying that, hey, things are around the corner. I mean, Sam Altman last year said, AGI was a couple hundred days away. Used that to raise a lot of money. And then now they release GPT 4.5, which was supposed to be GPT 5, but it wasn't just good enough to call it 5, and therefore they released the 4.5 and trying to change the tune. And we might very well have gotten to the kind of limits of where we can get with the current structure of LLMs. So I think there's this, always if we extend the line, the curve, we'll get super intelligence in 10 years kind of narrative. I'm not convinced that that's going to be the case. I don't think that if we stick with the current technology, which is pretty good, I mean, it's quite incredible the things that we can do, but there's still a lot of hallucinations. There's still a lot of issues with LLMs that mean, it might improve efficiency, but is it going to completely erase jobs? I'm not so convinced. I mean, the manufacturing sector, you need to make the right decisions 24/7, around the clock every year. If it's unfeasible that an LLM can run a factory, because it's unfeasible that 20% of my production LLM will say the wrong thing, and I will fail my quality test potentially. I mean, this is just it's not a possibility. And all of our models that we develop in-house, of course, are 99.999% accurate, which is quite hard to do with models. So all in all, I do think there's going to be changes in how the labor force is going to be structured. I don't think it's going to be a mass negative necessarily in the next 5-10 years, but 2050 is too far out. It could be that that there's another change in architecture of LLMs that might drive an increase by 10, 15 years. And I think we need to prepare ourselves not so much by slowing down research, because I don't think that's really possible. I think it's funny always that the companies that are promoting slowing down research are the ones that are doing, like, they want other people to stop doing research, which is, perfect representation of how the tech people think.
I think you cannot stop the curiosity of humans.
Yeah,
it will
yeah,
be
I think
impossible. There will be always one person to being a little bit more expanding into a segment which is even more interesting, which is maybe, ethical, etc., on the edge of it. Before we go into that discussion, like what you said, LM, you use your own, so you developed your own model. Just to give a 1-2 sentences about that, would be interesting.
Yeah, absolutely. Yeah, we develop our own models. LLMs, of course, work via text. Our models are models that work around understanding and approximating physical and chemical systems. So they work with numbers and specifically data coming from plants. So as a result, LLMs typically don't work as well in the kind of applications. So all of our models are time series forecasting, modeling, and specifically time when you have not just 1, 2, or 2 time series, but thousands. And all our models work on approximating and predicting these kinds of time series.
Specifically, you said steel is one of your focus areas. Is there any other 2-3 other major focus areas?
Absolutely, yeah. So steel is one of our top areas. Chemicals would be the second, kind of within chemicals, different verticals, also around CPG type of specialty chemicals, commodity chemicals, and then cement would be our third area of focus.
Okay, I think in one of the other interviews before, it was quite an interesting way of looking at it. It's kind of the human decision making versus the AI decision making, and it's a little bit touching that what we discussed before. Can you maybe describe 1 or 2 examples where you've seen, okay, the AI decision making was actually way better, but versus the human decision making? But where do we need human decision making in future to focus on to actually make the whole system better?
Yeah, ultimately, starting from the end, I think the combination of human decision making and AI, so AI augmented human decision making, is the part that it is definitely the right way to do things today. This is an interesting subject because you have some manufacturers that don't trust AI to be able to connect to just purely for AI-driven decision making. Others go, well, if we're going to have humans anyway, this is not worth it. We need to have full AI decision making. So I think I would say the industrial sector, even it's split in terms of how to think about things. Everything that we do is human-assisted decision making, so AI assisting humans on making decisions. And there's certain things that AI is very good at. It's very good at understanding, learning from a large set of data, and understanding.
Do you have some examples, maybe?
Yeah. So, for example, let's say steel example. Let's say a steel company has been manufacturing a particular type of product. Let's say making steel beams with a certain size for, again, let's say construction example. And one construction site asked them to make it slightly differently. Make it a little bit thicker on the side, and maybe the shape of the angle should be a little bit of an angle. And the plant the AI system has seen this type of production, a lot of production of this kind. So then it could actually propose a way to do this in an efficient way. But if the ask is to devolves too far out from the comfort area, if they're saying, no, this is a completely new type of alloy that we're asking for, then it's very hard for AI to make recommendations because there's not enough in this data set, in this training data, because they haven't made steel of this kind. Whereas humans are much better generalizing and getting out of the comfort zone of the available data, and this is why AI is not as useful if you're starting a factory for the first time. If it's greenfield deployment, I mean, there's no data. Well, I mean, how can you apply AI to it? So I believe the combination of AI doubling down on data that's in its comfort zone of previous production that has been run, combined with the human decision making, which gets them to explore other parts through domain knowledge and through expertise, that I think is the absolute winner, and that drives more value, in fact, as well.
And I think the difference by Fero Labs, like I think there is like a black box and white box AI. Maybe you can say one or two words about that. Have you ever had an aha moment where an engineer or a factory leader went from like totally distrusting AI to fully embracing it?
Yeah, definitely. In fact, I would say it happens almost every time we do a demo of our software. The subtlety there is this, that this is an area that we've been promoting since almost day one, and namely a lot of the AI models that are used in the enterprise world, not just in industry, but in retail or insurance and elsewhere, they're AI models that are built by typically academia or large tech companies for their own needs. So if you're a tech company and you're trying to forecast the load on your servers, for example, you don't need explanations. You just need really good predictions. Or as another example, let's say you're building a computer vision model that, upload an image and tells you what's on the image. I mean, you don't need to know why there's a cat on the image. I mean, clearly you would prefer to know for the model to tell you, I think there's a cat and this is why I think there's a cat, because it has ears and no. But ultimately you don't care. Just tell me what it is or which of my friends it is, and I don't need to know why. This is how most AI is built. Most AI models are built. This is how, chat GPTs and LLMs are built as well, which is a huge problem. In fact, this is the reason why they have hallucinations, is because they don't have explanations. If they had explanations or actual explanations, not just the reasoning type of model, then you would be able to figure out if they were hallucinating or not. So the type of AI models that we have developed, the issue that we have identified when starting Fero was that engineers don't want this. Engineers don't want some AI model that just tells you, hey, here's what you should do, without telling you why, or without telling you how confident it is in the why. Engineers want their goal, in fact, the entire reason Six Sigma as a practice exists is to understand the root cause. And you can only fix problems if you understand why they happen in the first place. So all of our models are explainable, and what that does, let's say in the steel world, is that an engineer can receive a recommendation and says, hey, add a little bit more carbon to this particular batch. And then of course the next question is well, why? Well, because this particular scrap that you just melted, it has high levels of, let's say, chrome in its content, and as a result, when you apply these kinds of rolling mill, temperature pressures at the rolling mill, it's going to cause this. Therefore, you should put a little bit less carbon. I'm making this up. So this kind of explanation, and combined with the confidence, every model will be wrong sometimes. Human models are wrong. But if models can convey how confident they are in their predictions, then engineers can actually make better decisions with that. They can go, okay, the AI says, Fero's AI says do this, and it's very confident, so I'll do it. And other times, Fero's AI say, you know what, I'm not really sure, because I don't have enough data with this particular type of production, and so just fall back to what you've been doing, before Fero's AI came about. And the interesting thing is that when we go into conversations with industrial folks, this is always comes up as the central theme, that they don't want to have a software that they don't understand, that is not explainable, running their factory for them, for fear that if they rely on it too much, then they will actually lose track of things, and things will start devolving slowly in the next years, to the point where they won't be able to run the factory without the AI. And if the AI is wrong, they'll run the factory poorly.
So coming to 2023, you raised, I think, 15 million, right? As a last investment round. My curiosity kicks in. What has been more the reason to fundraise for investors, the sustainability part or the AI part?
All of our investors from that round were climate tech investors, so definitely the sustainability part. I think our investors also saw that AI will play a key role in driving emissions down worldwide. There's different approaches to sustainability. There's many hardware process driven research that's happening, which is fantastic. Carbon capture is of course an example, but there's also examples around new types of steel making that is inherently less wasteful or emits less. In whatever setup you use, whether you use electrolyzers for hydrogen or carbon capture, doing things efficiently always improves your bottom line, basically. And as a result, our AI models, the thing that captured our investors' interest is that no matter which future direction we go through, if it's a hydrogen economy or if it's driven on carbon capture or about different trajectories towards net zero, if we keep wasting resources while running the factories, we'll never. It'll make our job so much harder. And we estimate that actually factories worldwide making decisions slightly better using AI can drive 800 megatons of emission reduction worldwide from the industrial sector's emission budget. So, and the other part is that in the Western world, typically plants are more optimal and they emit less. And the US specifically is doing great on the steel side in terms of emissions per ton of steel. But if we can't run factories in 5-10 years in the Western world because of labor shortages, then that's the worst case, because then we're shipping production elsewhere in the world where they might not have as good of a trajectory in terms of their emission reduction goals. And I don't see how, even with the current labor shortages, I don't see how any manufacturer will be able to produce steel in the Western world in 10 years without the assistance of AI. Things are going to get harder and harder. So we do think it plays a key role in driving emissions down, and that's what got our climate tech investors really excited, in addition to the AI part.
What are you going to use the money for? Like, what are the big pockets you're going to use the money for? What are you going to focus on? Which key priorities?
Yeah, so we're already working out of that round, and one of the big things that we've done in the last 2 years, of course, building up the team is ultimately always a goal with every round. Really excited about the team that we've built.
How many people are you now?
We're 23.
Can you share some numbers? Do you disclose some numbers, like how much revenue or anything like that?
We don't disclose revenue, but I can tell you that we have, in terms of the number of plants that we have on our system, we're around 24 that are actively using. We have multiple AI models running for each of these plants around the clock, as we speak. So yeah, the team building and of course expanding the go-to-market motion was a big goal for the round. The other part that's been really, really exciting is to build a new product that we've released just 6 months ago or so. That's been really, really successful so far, even though we just released it, around adding a whole other different way to help engineers troubleshoot problems easier, and have essentially kind of an agent system that's running around the clock that continuously monitors the factory, understands when things are not right, and then runs a whole report that provides this report to the engineers so that they can understand why things went wrong. So we rolled this out 6 months ago, and so very successful so far, and lots of interest across all of our sectors of focus. And yeah, so that's been the trajectory.
So soon raising again, or is it going to take a while?
Potentially, yeah, throughout this maybe Q4 or early next year, probably would be the timelines that we're looking at. So far, we're really focused on executing and hitting our next milestones. So fantastic. Yeah, so far so good.
So you are based in US, right?
I am based in the US, yeah. So calling in from Brooklyn right now, but we have an office in Germany as well, in Düsseldorf in Germany. And we've always had a German-US kind of DNA as well. I've actually, one of the first things we've done since when we raised our seed round in 2017 was to start our GmbH in Germany. So yeah, we're really excited about continuing to be a US-German company.
How is that right now feeling like?
Yeah, it's definitely interesting times. Interesting times for the German manufacturing sector, but lots of also positivity, in terms of what's coming up. And ultimately, one of the things that we've learned with the German industrial sector is that folks that are very, very resilient and they're very adaptive. They may not be the most agile necessarily, but ultimately, when they decide to take steps, they make really drastic steps and realign. And I'm seeing some signals of that these days, and I'm excited. I'm excited about the next. I think Germany will play a key role in continuing to be the bastion of industrial production of the Western world. I think it's unfortunate that we're going through a kind of protectionist era with respect to global manufacturing as well. But I do think ultimately we'll come out of this stronger, and Germany will come out of it stronger as well.
Like looking back, like 10 years is a long time. And it sounds like you are riding for a longer time on that as well, which I think is always great to hear to someone who's so passionate about what they're doing and actually want to build something longer than just 7 years. I really enjoy that. So looking back at, these 10 years, has been there like a setback what you really experience and think like, phew, that was really tough, and what did you learn out of it?
Yeah, I think the probably the thing that was an awakening was the realizing how hard it was to do enterprise sales as coming from a technical background and coming from academia. And I think we did a great job as technical founders, learn the ropes. And I think it is important for technical founders to understand well what it entails and what challenges come about, and to be close contact with customers. And I still, of course, try to be in close contact with customers. But that was a moment of realization that wow, this is really hard. There's so many moving parts, and I have so much more of an appreciation for, in general, go-to-market people, salespeople, including our sales team. It's really hard, man. It's really hard. So that was, I think, one of the things that was a first realization. And of course, the learning was that I think it's important that, again, the founders go through the sales period. But I think bringing on a professional sales team and marketing team early on would be probably the one thing that I would do differently, and knowing what kind of profile to look for these kinds of roles, because again, these are selling to industrial sector is very different to selling to data centers or other areas. And I think that generally in the tech world, technical founders don't look very highly on the sales folks and go to market people. And I wasn't actually one of those people. But I think I think every engineer should try to sell something in an enterprise world specifically to understand what it entails. And I think it's going to give them a whole new appreciation for the go to market people in their team.
I always said, like, I was in e-commerce before, everyone had to go through one day of customer service.
Yeah.
And that totally, it was a different appreciation for that job. What kind of requests
That's a great
came, what kind of
practice.
question. Yeah, it's really, it gives really a good perspective on it. Is there any like books or, podcasts or anything what you think significantly influenced you, like one of the AI side, but also on the sustainability side, which you could recommend?
Yeah, there's some. I think nothing comes to mind. I think the main podcasts are generally great, and I think there's some great podcasters, and including your podcast, Frederica. So I think I don't have any like specific recommendations on books or podcasts. I think generally I try to listen to these on a weekly basis, when I run or when I'm working out. And I think there's some great podcasts out there. I can't think of anyone that would be more valuable than others.
Thank you. Of course, Sustain Now is top of the list.
Exactly.
If you could erase one misunderstanding about AI from the public mind, what would it be?
I would say so it would be the top thing would be this distinction between black box, white box, and that specifically that not all AI is necessarily black box. And I think maybe a close second would be to erase the notion that AI is a net consumer of energy or of emissions, or creator of emissions, producer of emissions, and that's not necessarily, doesn't have to be the case in their AI systems that are more helpful for the emissions than hurtful.
That's actually, I think, the takeaway, what I usually ask as well at the end. So is that your one takeaway, which listeners should take with them? Something to think about long after this interview?
I would think so. I think I'm generally excited about the advent of AI, and I think we should approach it with not take the hype at face value, but approach it still cautiously, but also optimistically. I think that's my takeaway as well. Yeah.
And coming now back to your beautiful painted picture of green buildings and everyone is in flowers, amazing one. So what makes you confident that we actually can solve that climate crisis?
The part that makes me confident is the work of the science behind it, and the fact that we have, despite the policy parts, which changes course really quickly, science doesn't change course that quickly. I mean, funding of science changes course pretty quickly, unfortunately, which we're already seeing now. But the actual research itself doesn't, and there's always going to be people that will put their times and efforts and blood, sweat, and tears into developing science and technology that will help us towards that goal. So that's the thing that's I think is going to be the main driver for helping us get to that point by this utopia of 2050.
Great. Okay, thank you so much. I would have so many more questions in it. I think we definitely need to do a second round.
I'd be very happy to.
Yeah, I really enjoyed that conversation. Thank you so much for joining this podcast. Is there any way how people can contact you?
They can go to our website and reach out, so ferolabs.com, and we're a small team, so if they reach out, we would love to take any calls.
Fantastic. So thank you so much for joining today.
Thank you so much for having me.
Thank you for joining today's episode. You can find show notes, background materials, and guest details on our website, sustainnow.ch. If you enjoyed this conversation, don't forget to like, share, and subscribe. Got an idea for a future episode or an interesting solution we should explore? Let us know in the comments or visit sustainnow.ch to get in touch. See you in the next episode.